Okay, this morning we have some review from long ago and some review of the last lesson. Let's see how we're doing with all of this algebra. Number one, what did you get as the solution to that equation? Got 1, 2, 3, 4, 5, 6, 7, 8 confident people. We'll start with Kiana, so you get Dash, Michael, and then Caesar. Okay? You agree? All of you agree that it's negative 10? Correct answer is negative 10. What about number 2? What did you get for that? Ezekiel, Isabella, Michaela, and then Kivan. Negative 22. You agree? You agree as well? All 4 of you agree that it's negative 22. Nicely done. What about number 3? What do we get there? Start with Garion, Valerie, Alex, and then Gloria. 22. You all think it's 22? Correct answer is 22. Now, reviewing the last lesson. What do we get as a result of simplifying this complicated looking expression? What is the results? 2 confident people, and then 20 people that I'm just going to call on anyway. We'll start with Caesar, then back to Michael, then Jedli, and then Kivan.
I got 8 z to the 7th power divided by 24.
Okay. Say it one more time. So that's completely different. I'm sorry, I lost track. Garion, were you in there? Oh, Jedli, I'm sorry. Go ahead, Jedli. 1 over 3. So you agree here, and then I lost track again. I apologize. Kivan, go ahead. Say it again. 1/3. So that's the same thing. So we got 3 people who agree that it's 1/3. The correct answer is 1/3. Number 5. What do we end up when we simplify that expression? So now I'll start with Garion, Ezekiel, Chanel, and then Danae.
2x to the 5th power.
I got 2x to the 5th power.
Okay. Good, and I'm glad you recognize that that's the same thing, Chanel. So I think all 3 people agree. Danae, what do you think? You also agree. 2x to the 5th power. If you put it over 1, that of course is the same thing, so good job. What about this beast of an expression in number 6? What do we get when we simplify that? We'll start with Isabella, Joali, Paige, and then Sebastian.
2a cubed times b over c to the 4th power times 8.
That sounded complicated. Joali, what do you think?
2a cubed times b over c times the 4th power times 18.
I think that's what you said. Paige? Okay. What do you think, Sebastian?
G times b cubed times 8 over c to the 4th power times 3.
Seems like you guys all agree that that is the answer. So let's go, we're going to do the bottom 3 first. Let's go over to number 4. Give me a thumbs up if you got number 4 correct. Okay. Good. Gloria, what was the first thing that you did? If you can remember. I know you might have done it quickly, but. Okay, so I want to clarify something. So you said you added them, but this is a multiplication symbol. So what do you really mean? Okay, but you learned last time that when you do multiply the same base, what are you allowed to do? What? You add what? Very good. That's what I wanted to clarify. So, if you're multiplying the same base, you can add the exponents. And so what you end up with is 8, because we didn't do anything with the 8, times z to the 8th power over 24 times z to the 8th power. Chanel, did you do that same first step? Okay, and what did you do next? Cancel them out. So we've got z to the 8th over z to the 8th. They cancel each other out. And then we have 8 over 24. And then you just need to simplify. 8 over 24 is 1/3. Anyone have any comments or questions? One thing that I do think is a positive thing about this type of work is that it becomes very puzzle-like. And when I say puzzle-like, it's puzzle-like in the sense that there's a bunch of different ways to figure out the result, and it's really up to you to decide which path you want to take. And sometimes it can be interesting to try and find the most efficient path. So, like, for example, in number 5, if you only look at the top, you might notice that there's a 17 and a 2, and we can multiply them together. 17 times 2 is 34. Does anyone notice something different that we could do right from the beginning that might be more efficient than that? Chris? Yeah, there's a 17 on the top and a 17 on the bottom. So even though technically you're supposed to multiply these together, we already know that it's going to be divided by 17, so you could just immediately do that and that. Also, you might see that there's an x to the 3rd and an x to the 4th. So technically, we're supposed to do what Gloria said, which was same base multiplied, we add the exponents, you get x to the 7th. But what if you look down here, and instead of doing the top, what if you just say, oh, well, there's 2 x's down here, and that's going to cancel 2 of these. It's going to leave me with 1 of them left over. And so now the whole denominator disappeared, and that's why we got a 1. And then we've got x to the 1st, x to the 4th, that's x to the 5th, times 2, and that's why we get that result. Does anyone have any comments or questions? So there's different pathways to get to the same results, and it's up to you to decide what makes the most sense to you or what's the most efficient. Anyone have any comments or questions on anything at all from this warm-up? Anything, 1 through 6. Okay, put the warm-up. Today we're going to continue our preparations for Algebra 1 Honors. For the last few lessons, we've been studying exponents, what they mean, how to work with them. Today we're going to continue that by studying zero exponents and negative exponents. We do zero and negative exponents separately from the rest because they behave very differently. In fact, they do not function the way you think they would. So, one of the ideas is very easy. One of the ideas is very challenging. So we're going to start with the easier one, the idea of a zero exponent. Any number, or for that matter, any variable, anything to the 0 power is equal to 1. Now, I'm not saying that anything to the 0 power really means to the first power. What I'm saying is the entire expression becomes a 1. So for example, a to the 0 power, the entire expression is equal to 1. This idea is simple, yet seems strange. When first introduced to it, your brain doesn't really quite understand why. Why is it become a 1? And I'm going to show you why it becomes a 1. The explanation will be coming in about 3-4 minutes. But I just want to clarify. Here's a bunch of examples. 4 to the 0 power becomes 1. Negative 9, that's the base. The exponent is 0. That whole expression really has the value of 1. That's what we're talking about, value. X to the 0 power has a value of 1. This is the easier concept of the day because there's nothing to do. There's nothing to do except know what it's supposed to be. Yes, Gary.
So basically, if there was an expression where they had a number to the 0 power and then there was other stuff in the expression, it would still equal 1.
So I'll do a more complex one. We're going to see this in our examples, but you're talking about x to the 0 power y to the first, I'm sorry, let me do it different, y to the third, z to the 8th. Something like that?
Sort of not.
Okay, sort of not really. Why don't you make up the example?
Like, I don't know, x to the 0 power. Something that has numbers other than simply exponents. I'm not sure.
Okay, so you mean like this. So you mean like 14 x to the 0 power y to the 4th power. Okay? What it means is the expression that has the exponent of 0 is a 1. That is a 1, and that is a 1. Literally, this means 1 times that times that. 14 times x to the 0 times y to the 4th means 14 times 1 times y to the 4th. Any expression that has a 0 exponent is a 1. So in your mind, replace it with a 1. You'll also notice that I started putting multiplication dots. That's a practice we're going to start today as well. So, let's continue on. Again, this is the easier of the concepts. The harder concept is negative exponent. A negative exponent does not mean what you think it means. Negative exponent really means reciprocal. And this is very, very challenging because your mind thinks that a negative exponent should mean something else. And because it doesn't, your brain is rebelling against the idea. Your brain is going to say, well, no, I don't want it to be a reciprocal. I don't like that, so I'm going to make it something different. I'm going to explain how to deal with it in a fairly simple way. And it's just a matter of trying to practice and understand. But a negative exponent means reciprocal. So, for example, a to the negative n really means you flip it. That's what a reciprocal is. You flip it and then change the exponent to positive. So, for example, if we have 5 to the negative 3rd power, that really means 1 over 5 to the 3rd power. Now, where did the flip happen? Well, let me show you. Any expression really has a 1 underneath it. So reciprocal means flip it. And so we flip the 1 to the top, and this goes to the bottom, and then we change the exponent to positive. That's how you deal with negative exponents. This is going to take practice. It's going to take time for it to sink in. Initially, it's not going to make a lot of sense. It's going to get complicated. You have to follow along with what I'm teaching you, and it will start to make sense. Now, it also works the opposite way. If I have a negative exponent in the denominator, you flip it, and it ends up in the numerator. And then you change the exponent to positive. Every time we flip, you are changing the exponent to positive. Now, this doesn't work with positive exponents and then you flip them to negative. That's not something we do. We're talking about negative exponents only. Again, it's going to take some practice. So, 0 exponent means the whole expression is equal to 1. Negative exponent really means reciprocal. Before we get into some practice questions, we're going to go to an explanation. And so what I would like you to do is go to the side of your paper. Just find some space on the side, and I would like you to write 2 to the third power, leave a line of space, 2 to the second power, a line of space, 2 to the first, 2 to the 0, 2 to the negative 1. Write that down, just the side of your paper, and leave some space. So this is the explanation. This is the y. Y is a 0 power equal to 1. Y is a negative exponent, mean reciprocal. So start with the very top. 2 to the third power. What is 2 to the third power equal to? What is its value? Udesh? How'd you get that? Very good. It has a value of 8. So everyone, please write equals 8. 2 to the second power. What is its value? 8. How'd you get that? 2 times 2. So that has a value of 4. Now we're going to pause, and we're going to go back to the top. What do you do to the 8 to get the 4? Michael? Divide by 2. 8 divided by 2 is 4. Let's continue what we were doing before. 2 to the first power. What is 2 to the first power equal to? Gloria? 2. So everyone write equals 2. But how do we get from the 4 to the 2? Selena? We divide by 2. Now, 2 to the 0 power. Let's pretend for a moment that we don't know what it's equal to. Okay, because before you started today, you didn't know that equal to 1. Let's pretend for a moment that we don't know what it's equal to. So we don't know what to write right here. In other words, I wrote in blue, blue, blue. I don't know what to write in blue here. But I can follow a pattern because I'm very smart. And so I see a pattern here. Divide by 2, divide by 2. To go from here to here, divide by 2. What is the result? Gary? It is 1. So that is why anything to the 0 power equals 1. Because this happens no matter what example you use. You could do 12 to the third power, 12 to the second power, 12 to the first power, 12 to the 0 power. Figure out the pattern is divide by 12, divide by 12, divide by 12, and you will end up with 1 again. No matter what number you do, and it could be a negative number. You could do negative 4 to the third power, negative 4 to the second power, negative 4 to the first power, and negative 4 to the 0 power. And the pattern will be divide by negative 4, divide by negative 4, divide by negative 4, and this will equal a 1. It will work every single time, no matter what number you choose. Does anyone have any questions about why anything to the 0 power is 1? Let's continue. And now let's look at 2 to the negative first power. Right now, I still don't know what that is equal to. I'm confused. I have no idea what to write in blue right here. But I can follow a pattern. And so I can take the 1 follow the pattern, and the pattern is divide by 2. What do we get when we do 1 divided by 2? Yvonne? Yeah, you get 0.5 or 1/2. How do I write 1/2? I write it as 1/2. And so you see that the 2 jumped to the denominator, and the part that maybe some of you are curious about is, well, what happened to the exponent? Well, it's still there. 2 to the first power is 2. So the only thing that changed was this negative disappeared. This continues. 2 to the negative second power. Again, I have no idea what that's equal to. But I can follow a pattern of divide by 2. What do we get when we divide 1/2 by 2? Chanel? Yeah, you get 1/4. But let me write it differently. 1/4 is really 1/2 to the second power. 2 to the second power is 4. And so what is really happening with negative exponents is this exponent makes the whole thing jump to the other side of the fraction, and then we change the exponent to positive. And that is the explanation of why. And this would work with my other examples that I wrote out quickly here. No matter what, this will continue. Okay? Isabel?
So if that were the answer to a question, would you put 1/4 or 1/2?
You can put 2 squared or 4. My policy is if it's something simple like 2 squared, you can change that to a 4. But if it was like 2 to the 20th power, don't bother. The whole point of exponents is to write complicated things in a simple way. For example, many of you failed to realize the purpose of the last question on the homework. The last question on the homework, the purpose was to write it using exponents. Who wants to write out 22 zeros? Nobody. That's why we write it using exponents. So that was really the purpose. Okay? Any other comments, questions? So now we're going to start using these ideas to simplify expressions. So, you might see instructions that say evaluate. You might see instructions that say simplify. And you see that it says write your answer as a fraction in simplest form. And so you're going to have to learn how to use your understanding of these different ideas to change the way things look. And again, I go back to the same example I've been using since the beginning of the year of making a dollar. A dollar bill is worth $1. It has a value of $1. But 4 quarters looks totally different, but still has the same value. That's all we're doing. Okay? So, the first few examples, you're going to need my guidance. You're not going to understand. Or you might not understand. So just wait for my guidance. If you think you know what to do, then you can go ahead and do it. So, part A. We have negative 2 to the 0 power times 1/4 to the negative second power. That's a complicated looking expression. But let's start with the negative 2 to the 0 power. What is anything to the 0 power? Ezekiel? A 1. So in actuality, this says 1 times 1/4 to the negative second. I'll take it a step further. Do we have to write 1 times something? 1 times something just means leave the number or expression the way it is. So in actuality, when you're talking about multiplication, this has no meaning whatsoever, and so that's really the expression. That is really a 1 and really has no meaning whatsoever. Which leaves us with 1 over 4 to the negative second. And now I'm going to explain what to do. All negative exponents get bumped to the other side of the fraction. There's always a fraction. Here is the fraction. Here's the fraction bar right here. And I'm just going to extend it a little bit. All negative exponents, before you do anything, they get moved. If you see a negative exponent, you move it. So this is in the denominator. It's going to move to the numerator, and then the exponent sign is going to flip. So this is going to disappear from the bottom, and it's going to reappear on top as 4 to the second power. So in actuality, we have 1 times 4 to the second power, and there's nothing left on the bottom, which means there's a 1 on the bottom. So this is actually not that complicated. It's just 4 to the second power. You can write your answer as 4 to the second power, or you could actually evaluate it and write 16. I would accept either answer. Isabel? You could, but the 1 in the denominator has no value. Doesn't change its value, doesn't do anything for us. So we just write it without the 1, but if you want to put it over 1, that would be acceptable as well. Any questions so far? All right, part B is where we start working with things that are like puzzles. And it's your job to try and view things the most efficient way. So we have 3 to the 5th power times 3 to the negative 7th power. And so anytime you see a negative exponent, you have to move it. That's your job. And it goes to the other part of the fraction. Well, I don't see a fraction. Caesar? That's right. There is always a fraction. There's always a fraction. And he's right. There is technically a 1 down here. So basically, you got to train your eyes to find a negative exponent and say, oh, there's a negative exponent. That's got to move. It's on the top. I'm going to move it to the bottom. It's going to disappear, and it's going to turn into 3 to the 7th power. I'm going to rewrite it so it's a little clearer. The only thing I have left on top is a 3 to the 5th. And the only thing I have on the bottom is 1 times 3 to the 7th. The 1 is not really doing anything, so I've got 3 to the 7th. Now I'm going to use my knowledge from previous lessons. I have the same base, 3 and 3, and I have exponents. I have 5 3's on the top and 7 3's on the bottom. Don't write this, but I want to remind you that this is what it means. 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3 times 3 times 3. That's 5 of them on top, 7 of them on the bottom. Your mind should be doing this for you, because watch what happens. That cancels that. That's that. Cancel, 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 and I'm left with 2 of them on the bottom. But this class doesn't need to do any of that. This is a waste of time for this class, because we are so advanced that we can say to ourselves, oh, there's 5 3's on top and there's 7 on the bottom. These 5 are going to cancel 5 of those, and there's going to be 2 left. I have nothing left on top, which means that I've got 1 over 3 to the second power. So I can either write my answer as an exponent, I can write 1 over 3 to the second power, or you could write 1 over 9 because 3 to the second power is 9. I would accept either answer. Does anyone have any comments, questions? Gary?
Is it okay if we don't add the 1 on the top?
No, you have to add the 1 on top. The only time you don't have to is when there's a 1 on the bottom. Have you ever seen anything that looks like this? Never seen that before, right? Because it doesn't exist. Have to put the 1 on top. 1 on the bottom doesn't change the way it is. The 1 on top is important. Yes?
I did, alright, in equation, I did the 3 to the bottom. I thought it was 1 there.
Well, that's what you're learning today. Negative exponents move to the other side of the fraction. This negative exponent is on top. It has to move to the bottom. That's the way negative exponents work. That's what you're learning today. So now it's on the bottom.
So when you move the exponent, you move the number that's
The 3 to the negative 7th are linked together. It's not two separate things. Okay? Good. Let's continue. Part C. Negative 4 to the negative 3rd power. It's a negative exponent and it's on top of a fraction. How do I know it's on top? Because I know. There's a 1 underneath. Negative exponents have to move. This whole thing is the negative exponent. That has to move to the other side of the fraction, so it's going to disappear from here and it's going to show up on the bottom as negative 4 to the positive 3rd power. Only the exponent sign changes, the base does not change. So now I have only a 1 left on top, and on the bottom I have 1 times negative 4 to the 3rd power. Now, just make sure you've simplified everything. The only thing left on top is a 1. The only thing on the bottom, this 1 doesn't have any meaning, so this is just negative 4 to the 3rd power. If you're really kooky, you can go ahead and simplify that to 1 over negative 64, but you might as well just leave it in exponent form. Does anyone have any comments or questions? Good. Part D is here to illustrate something that I didn't illustrate in Part B. It's almost the same exact example. 6 to the 12th times 6 to the negative 4th. Now, what I've been saying over and over again is that a negative exponent has to move. You see a negative exponent, you have to move it. But now you have a whole bunch of different techniques at your disposal in your brain. Gloria is going to remind us of something she did during the warm-up. So let me change the question. I don't want you to change it. I just want you to watch. I'm going to take this negative 4, and just for a moment I want to change it to a different question. So let's pretend that it's 6 to the 3rd power. Gloria, what would I do if I have 6 to the 12th times 6 to the 3rd? What do I do? Very good, because it's the same base. You add the exponents, and you would end up with 6 to the 15th power. So how about we just do that? This is the same base. Add the exponents. Just because it's a negative number doesn't mean you can't add it. So what's 12 plus negative 4? Michael? 8. So we're already done. This is going to equal 6 to the 8th power. Now I could do it the long way. I could do it, and it's not really long, it's just different. I could say, oh, well, Mr. Gowd said all negative exponents have to move. So I see a 6 to the negative 4th power. That's on top. I need to move it to the bottom. So that's going to disappear and become 6 to the 4th. And now I would say to myself, okay, I've got 6 to the 12th over 6 to the 4th. This is 4 6s. That's 12. Those 4 are going to cancel 4 of those, and I will have 8 left over. And wow, like magic, I end up with the same answer. And you should end up with the same answer. So it doesn't matter which way you approach it. I could have half the class do it the original way we do it, and I could have half the class do it this way, and I don't really care. You have a store of tools in your mind. You have rules for exponents, you have negative exponents, you have these different rules that you can use in different combinations. Okay? Does anyone have any comments, questions about that? All right, so you've seen 4 good examples. Let's see how you do on your own. Checkpoint number 1, you've got 2 questions. You're going to be using the dry erase board. Now you have to divide the dry erase board in half and do part A on the left and part B on the right. Got 3 minutes. Remember, you don't have to copy the question. Remember, you're trying to write big so that it's easy to see. Make sure you circle your answer. All right, pick up your boards. Put your boards down. Do not erase until we check answers and discuss. So, part A, let's see who's confident in their answer. What'd you get? Caesar, Keanis, and then Chris. What'd you get? Okay. So the correct answer is, oh, where's my answer? 1. Part B, what did you get? Start with Yadesh, Garian, and then Joel. Okay.
1 over 64.
Okay. Okay. I will accept either answer, 1 over 8 squared or 1 over 64. Either way. Okay. So, part B, pretty basic. But I want to talk about part A because there was like 3 or 4 different ways to do it. I strategically chose this question on purpose. So now I want to know what you did. What did you do to get it right? Paige?
I added up the exponent,
And you got what?
so that would be like 10.
That's right. So multiplying same base, you add the exponents and you get 10 to the 0 power. And then that equals 1. Anything to the 0 power is 1. Anyone do it differently? Chanel? Good. So let me rewind for a second. You put the whole thing over 1. Very good. And that's a negative exponent, so it has to move, and you moved it down here, and it turned into what? 10 squared. Oops, sorry, 10 squared. Very good. And then what'd you do? Yeah. Now you have 10 squared over 10 squared. 10 squared over 10 squared, it's the same thing over itself. That's going to cancel that, and you end up with 1. 2 totally different approaches. Anyone do it totally differently? Very good. There was a lot of you who got both of them right, and I'm very impressed. And I want to tell you something. Most of what you did is the exact same lesson that I do with my Algebra 1 honors students. So you guys just not only did pre-algebra, but you actually did a full-on Algebra 1 honors lesson, and many of you passed with flying colors. It will get a little bit more complicated next year, but you already are you're already demonstrating that you can do it. Okay? So if you got them both right, you should be incredibly impressed with yourself. If you didn't get them right, it doesn't mean you did something wrong or something bad. It means you didn't get it yet. You've only seen 4 or 5 examples. Now we're going to start working a little bit more. So erase your board and go back to our notes. Now we're going to do more of the same, but I'm going to add in one little technique that will save you from making simple mistakes. So, rewrite with positive exponents. This is a common set of instructions that you will see as well. So, part A. 3x to the negative 4th, y to the negative 5th. I don't want you to copy it. Stop. Here is the technique that I'm adding in, and you're going to start doing now, and you're going to do for the rest of today, and you're going to do tonight in homework, and today during classwork. Anytime you're working with something like this, is when you write it down, put the multiplication dots into the expression. This really says, excuse me, 3 times x to the negative fourth times y to the negative fifth. When you write it down, you're going to write it like this. So now go ahead and write it down like that. You're going to see why this is important in a moment. I am trying to save you from the most common mistake. So let me rewind for a second. You copy that down. I'll put this back in a second. Here's the most common mistake, and keep in mind that I've been teaching Algebra 1 Honors for a long time. My students go, okay, Mr. Gadd, I get it. Negative exponents need to move. There's a negative exponent right there, so I'm going to move that to the bottom. And here's what they do. They move the 3x to the negative, and they change it to that. Doesn't seem like a big deal, right? The problem is that the 3 is not connected to the x to the negative fourth. The 3 doesn't move. Only the expressions with the negative exponent move. So what I developed was this idea that if you write everything with multiplication dots, then you're instantly reminded that the 3 is really separate from this. And so that is why we're going to do this, because we want to make sure we don't make this simple mistake. So now we can see this, that this is really over 1, like Caesar explained earlier. And now negative exponents move. X to the negative fourth, that is a negative exponent. That is going to disappear from the top and it's going to move to the bottom. And the sign on the exponent flips, so that becomes x to the fourth. Here is another negative exponent that is also going to disappear from the top and is going to move to the bottom. And that will become y to the fifth. Now check and see if anything else can be simplified. 3 is prime. X to the fourth, y to the fifth. There's nothing else you could do. They don't have the same base. So now we are done. We have simplified and we have rewritten with positive exponents. Here's what it looks like as a final result. That is the final result. Does anyone have any questions about that? So, part B, we're going to do this again. Don't write it down like this. You're going to write this. 1 over 7 times y to the negative fourth. So you don't make the foolish mistake of moving the 7 with the y to the negative fourth. Now you can say, oh, well, there's a negative exponent. It needs to move to the other part of the fraction. It's going to disappear from here and move up here. And it's going to be y to the positive fourth. Now rewrite, now simplify anything that needs to be simplified and rewrite the final expression. There's nothing else to do here, nothing else to do here. We end up with y to the fourth over 7. That is the final result. Does anyone have any questions about that? So you shouldn't have written it down like this. You should have written this. And that was to force you to see just the negative exponent right there. That's going to disappear, and it's going to jump down to the bottom of the fraction, and that's going to be d to the fourth. But now we have our first case where that wasn't enough, because now we have the same base being multiplied. So what will the denominator become? Isabella? That's right. That's Gloria's rule from way back during the warm-up, that this is multiplied, same base, you add the exponents, and so our final result is 7 over d to the 6th. If you do not simplify that step, then you will not get the right results. Okay? Anyone have any comments or questions about that example? All right, to the boards again. Checkpoint number 2. Let's see how you do with these. You've got 2 questions. You've got 3 minutes. When the bell rings, you hold up your board. Okay, put your boards down. So, part A, 0.7 over n to the 5th power. Part B, y squared over 12x to the 4th. And so that one was a little bit tricky because you had a negative exponent on top that had to move to the bottom, and a negative exponent on the bottom that had to move to the top. So, part B, here's what my process looked like. I wrote it down initially like this, so that I didn't make a foolish mistake. And then I said, oh, well, I have a negative exponent on top. That's got to move to the bottom. So it's going to disappear and turn to x to the fourth. But I have a negative exponent on the bottom. That's got to move to the top over here. That's going to disappear and turn to y to the second. And so that's on top. All of this is on the bottom. And that's it. Okay? Comments, questions, concerns on either of these? All right, erase your board, back to your notebook. Classwork is going to be on page 204. You're doing numbers 31, 33, 35, 37, 43, 47, and 49. Got 7 questions. Got 10 minutes.
Oh, I know. To the second. 3t to the 8th power over
So, pick up your colored pens. And I will say that number 31 was a tiny bit unfair because I didn't prepare you for it, but it really just meant to go in reverse of what we did today. So if you didn't get number 31, don't worry about it. You'll see what it means in a moment. So, number 31. We spent today taking negative exponents and rewriting them as positive. That question was asking you to do the opposite, to rewrite the positive one. This one, to get rid of the fraction bar, we take this and move it to the top and then make it a negative exponent. Number 33 is 1 over 5 to the 4th power. If you did 5 times 5 times 5 times 5, I believe that's 1 over 625. That's fine as well. Number 35 comes out to 13 to the 6th power. Number 37. Number 37 is 15 over t to the 11th. 43, 1 over 2 to the 3rd power, or 1 over 8. Number 47, 1.7 over a to the 4th power. And then number 49 comes out to 2w to the 8th power. So there were 7 questions. Make a fraction out of 7. Hopefully you got 5 out of 7 or better, which was approximately a 71%. If you did not do that well, that's okay. We're still in the middle of the learning process. Draw a line across your paper. Your homework is on page 204, numbers 16 through 50 even, and that is a total of 18 questions. You're going to have a quiz on Friday on chapter 4. So we did 4 lessons in chapter 4, so just those lessons.